Friends, in last session we were discussed about question number 1 of exercise 2.2. In today's session I am explaining question number 2 about to find the quadratic polynomial. Let's see the question first. It is the question number 2 from our textbook exercise number 2.2. Find a quadratic polynomial each with the given numbers as the sum and the product of its zeros respectively. There are two numbers are given. First number is the sum of its zero and the second number is the product of its zeros. Its zeros matlab the zeros of the quadratic polynomial. See the first one. In the first one, two numbers are given. One number is 1 upon 4 and the second number is minus 1. First number is called the sum of zeros and the second number is called the product of zeros. It is for our convenience. Sum of zeros is equals to 1 upon 4 and product of zeros is equals to minus 1. We all know the standard form of quadratic polynomial p of x is equals to ax square plus bx plus c. If we have the values of a, b and c and we substitute the values instead of a, b and c and simplified the given terms or some multiplication, we obtain a quadratic polynomial. That's why we need the coefficient of x square a, coefficient of x b and c is the constant term. X square and x remains as it is by using the sum and the product of the zeros using given two numbers. First of all, let us take alpha and beta are two zeros of required quadratic polynomial. Let alpha and beta are zeros of required quadratic polynomial p of x. We know the quadratic polynomial, standard form of quadratic polynomial ax square plus bx plus c. Using the sum of zeros and product of zeros, first we have to find the coefficients a, b and c. Make the two parts between the page. Left hand side we have to take sum of zeros. Zeros are alpha and beta, then sum is alpha plus beta. Right hand side take a product of zeros. Product of zeros. Alpha and beta are two zeros, then the product of zeros is given by alpha into beta is equals to alpha into beta. Alpha plus beta read as sum of zero. Alpha into beta read as product of zeros and both are given. Sum of 0 1 upon 4 and the product of zeros is equals to minus 1. First of all, make the denominators equal. Here denominator is 4, here nothing in denominator. Then first of all we have to put here 1, nothing, then 1. We know alpha plus beta is equals to minus b upon a, and alpha into beta is equals to c upon a. See the formulas, both denominators are same, which is a is the coefficient of x square. Here both the denominators are different. Then first of all make the denominator equals. We multiply this term with 4 and divide by 4. Multiply with 4 and divide by 4. 1 4s are 4 and both denominators are equal again. Second thing, alpha plus beta is equals to minus b upon a. But 1 upon 4 does not contain any minus. That's why we multiply 1 2 times as a minus upon 4. Is equals to minus 1 multiply 4 is the minus 4 upon 4 ones are 4. Now see the comparison. Both the denominators are equal. Two most important steps are there. Both denominators are equal. Yes. Then check second thing. Second thing is a minus for alpha plus beta. Minus is here. Yes. Minus minus plus and it gives 1 upon 4 above step. Is equals to, it is look like as minus b upon a, and the right hand side product of zeros is equals to c upon a. Here we are writing here the values of a, b and c. Both denominators are equal. AA is equals to 4, a is equals to 4. Now compare minus with minus, outside minus, close it. And the b is equals to the bracket is equals to minus 1, b is equals to minus 1, and remaining c is equals to the numerator. Compare numerator with numerator. C is equals to minus 4, c is equals to minus 4. Now we substitute the values of a, b and c in the standard form of the quadratic polynomial. Required quadratic polynomial p of x is equals to ax square plus bx plus c. Now we substitute values of a, b and c in this form. Instead of a is a 4, x square remains as it is, plus instead of b is a minus 1, it is a minus, then put it into a bracket, x as it is, plus instead of c is equals to minus 4, again into the bracket, 4x square as it is, plus minus 1 multiply x gives x, plus minus 4. 4x square minus x minus 4 is our required quadratic polynomial. But there are lots of polynomial whose sum and the product of zeros are 1 upon 4 and minus 1 respectively. Therefore, in general, required quadratic polynomial is, we multiply k with this polynomial, k into bracket 4x square minus x minus 4, where k belongs to R but minus 0. K is a non-zero integer. Instead of k belongs to R minus 0, we can also write k is a non-zero integer. It is for you, or k is non-zero integer. Okay, now we verify it, our polynomial is correct or not. Then we go for next. 4x square minus x minus 4. From that polynomial, first the coefficient of x square a is equals to 4, coefficient of x is equals to b minus 1, and the constant term c is equals to minus 4. By using the formula, we need to find sum of 0 and product of 0. We know sum of 0 is minus b upon a, minus instead of b is minus 1, instead of a is 4, minus minus plus 1 upon 4. See, the 1 upon 4, it is a sum of the zeros. Now product alpha into beta. We know alpha into beta is c upon a, where c is equals to minus 4 and instead of a is equals to 4. Now 4 cut, remaining minus means the minus 1. Minus 1 is the product of 0. Now it is the question. 1 upon 4 and minus 1. 1 upon 4 is the sum of zeros and minus 1 is the product of 0. Hence the question is obtained here. That's why the required quadratic polynomial is 100% true. You can verify all the polynomials like this method. Okay. Now we go for second number. In the second, first number is sum of zeros and the second number is the product of zeros. For our convenience, sum of zeros, it is not compulsory to write here, is equals to root 2, and second, product of zeros is equals to 1 upon 3. Same method will be applying here. First of all, we have to take two zeros. Let alpha and beta are zeros of required quadratic polynomial. P of x is equals to ax square plus bx plus c. Now we are going to find the coefficients a, b and c. Make a line between the page. Left hand side, sum of zeros is equals to alpha plus beta, and right hand side take a product of zeros is equals to alpha into beta. Now we know alpha plus beta and alpha into beta. Alpha plus beta is a root 2. Sum of zeros is equals to root 2. And the alpha into beta, it is a 1 upon 3. The product of zeros is a 1 upon 3 is equals to 1 upon 3. There are two most important conditions are there. First condition is make the denominators are equal. They are equal? No. Root 2. Nothing in denominator. Then we have to put here 1. Root 2 upon 1. Now see, the denominators are equal. Here is the 1 and here is the 3. No, they are not equal. Then what to do? We multiply root 2 upon 1 by 3 and divide by 3. 3 ones are 3, we obtain 3, then both the denominators are equal. Again, the one question is remain here. Alpha plus beta, it is a minus b upon a. Here no minus, that's why we multiply 2 times as a minus is equals to, we multiply root 2 multiply 3 gives 3 root 2 upon 3 as it is, 1 minus outside the bracket and 1 minus is inside the bracket. Now compare alpha plus beta minus b upon a. Alpha into beta, c upon a. Both denominators are equal. A, 3, 3. Yes. Then go to next. Our next step is see the minus. Minus is here. Yes. Then write next step is equals to minus b upon a and is equals to c upon a. On comparing minus b upon a with above term and c upon a with above term, we obtain the values of a, b and c. Now a is equals to 3, a 3, then a is equals to 3. B is equals to, compare minus with minus, outside minus, close it, then B, take a B as the bracket, minus 3 root 2, minus 3 root 2, and C is equals to numerator, C is equals to 1 because C is in numerator, then C is equals to 1, here is the 1, therefore required quadratic polynomial p of x is equals to ax square plus bx plus c. Now we put the values of a, b and c. Instead of a is 3, x square as it is, plus instead of b is a minus 3 root 2, minus 3 root 2, x remains as it is, and instead of c is equals to plus 1. Simplify, 3x square plus minus minus 3 root 2x and last is plus 1. Here 3x square minus 3 root 2x plus 1 is our required quadratic polynomial. But lots of quadratic polynomial we are obtain here whose sum is the sum of zeros is root 2 and the product of zeros is 1 upon 3. That's why in general required quadratic polynomial is p of x is equals to, multiply this polynomial by k into bracket 3x square minus 3 root 2x plus 1 where k is non-zero integer or otherwise write in symbolic form k belongs to r minus 0. The two examples are of quadratic polynomial whenever the sum and the product of zeros are given. To verifying this polynomial is correct or not, how to verify, now you all are capable for that. In next session we learn the next questions.